We're going to talk a little bit more about technology near the edge now. We have Tschudi Yohann from Yole. They're a market research firm, and Tschuti's going to go in and talk about AI at the edge, discrete components, integration of that functionality, market forecasts, by use case and all that sort of thing. So I'll hand over to Tschudi.
Thank you very much for the introduction. So what I'll try to do today is to explain the vision of Yole, our insights about the fact that artificial intelligence is moving to the edge and what's the impact on the semiconductor industry. I will particularly focus not on software, but more on computing hardware and the related applications. So this is an image that in all marketing companies we like to do. This is what we think about what will be the augmented intelligence and when it will happen. So first, if we look at the past, we had a personal computer, we had a mobile, and it combined to get the smartphone we have today, and artificial intelligence get to play here. If we look at what is happening now, we get more and more smart things, okay? And this smartness means something very special. It means that we will have, at one point, artificial intelligence in these systems. If we go to look a bit in advance, in 5, 10, 20, 30 years from now, we see that this artificial intelligence will go into systems like companion robots, like robot home. We are already seeing this thing now, but it will be all around us. And at one point, we can think that why do we need artificial intelligence in this kind of systems? Well, the thing is that what we want to do is to get systems that are at least, and for dedicated tasks, as intelligent as a human, as smart as a human, okay? But at one point, these systems will be smarter than human to do some dedicated task. And if we look at science fiction, we will go through this tremendous idea of augmented human. For this talk, I will focus on edge computing for consumer applications. We can look these problems, this study on different point of view, but the thing is that for us, what is important is to understand how it works. And on computing hardware, there's two ways to introduce artificial intelligence in systems. The first one is as a standalone chip, okay? We have seen that for the last 20 years. It's common, it's something usual. The other way is to embed a unit, a dedicated unit for artificial intelligence algorithms inside a SoC, system on a chip. I will not spend a lot of time on audio. It will be spent on imaging, but this is kind of something you have to keep in mind. Audio AI is coming through, and we will see that too on the edge soon. And finally, I will describe some application. I give some examples in smartphones, in drones, and what we call robotic home. Why we focused during the last year on this only on imaging on audio? Because, well, in imaging on audio, there is a clear need of artificial intelligence, and the technology is ready. You are here, you have seen a lot of examples yesterday and today. It's working. In other domains, like that covers all other senses we have, olfactometry, for example, or what we call smell recognition, it's not quite ready. And in other domains too, like motion sensing, for example, we don't need artificial intelligence. It's working pretty well like it is now. If we look at the trends, we have two different kinds of trends. The first one is about the architecture, and the other one about the location. I will start on the location. My talk is about edge computing, and we see clearly that we are going from cloud to edge computing. There is plenty of reason, and I will talk about that later in my talk. On architecture, we see three different types of architecture. First, it's decentralized. We are used to it's personal computer, the old one, when you have your GPU card, your CPU on the motherboard, the sound card, all was decentralized, and each card is on its own purpose. With the smartphones, we came into centralized computing with the application processor, where everything was in units in only one chip, piece of silicon. And today, what we see is that because of many reasons, but the most important one is the Moore law, which is decreasing clearly. We see that we need a dedicated architecture for what we want to do. And artificial intelligence is the best example. What we can see in smartphones today with the neural engine, what they call neural engine or neural processing unit, or what we begin to see in a sound processor. So let's talk a bit about imaging and what we see in dedicated hardware for AI. When I'm talking about embedded, I'm talking about what we call a unit, a vision processor unit. So it's a unit embedded within the system application processor. And this unit is not working alone. I mean, it's not doing the whole stuff alone. It's working with CPU, with GPU, with all the memory around. And that's kind of a full, nice piece of system that is doing artificial intelligence. Don't miss the point that a neural engine is just computing the weight and the functions inside the neural network. It's not doing the whole stuff alone. For vision processor, it can be a SoC too, but it's dedicated to do imaging computing, computer vision or artificial intelligence algorithms. If you want to have an example, keep in mind that a type of vision processor we see is Intel Mobileye for automotive or Movidius, for example. This is the definition of what we call a vision processor. Whether it's a vision processor or a vision processing unit, the goal is always the same. It's to understand the environment around the device. Let's begin with smartphone. For smartphone, as I said, we have today AI dedicated unit that comes with A10, with Apple, and processing AI application with a dedicated unit is, in the same time, faster and it consumes less energy. That's the main point of using a dedicated neural processor than using the GPU inside the application processor. There is no dependence on internet connection. Everything is done inside the application processor. There is an improvement of privacy. And this is something that we can see today. We can even use the data stored in the smartphone to improve more and more the artificial intelligence applications too. And obviously, there is less latency. The thing is that to get to there, there are a lot of requirements. On the software side first, where artificial intelligence needs, even if we see that we can have better algorithms, but today we see that we have a high computational need. It needs to be done in real time. It's always on systems. And for what they want to do today, or for what we see in smartphone application, usually it's a huge neural network. There is obviously the mobile environment constraints with the thermal efficiency, with the low consumption for battery life, and for memory limitations. So here is an evolution of what we have seen when I'm talking about the trend from decentralized to centralized to specialization. Here we are already in the centralized trend, but we can see that in 2010 we have just a CPU with a piece of GPU. Then with A6 for Apple, we have multiple GPU units with CPU, with memories. And since 2018, we have a dedicated unit, which is the NPU. So here, it's the clear example of what is the trends today in smartphones from centralized computing to specialized computing. If we look at the supply chain, there is interesting things too. The thing is that we can consider two different segments, two different types of players. The first ones are the classical OEMs with Apple, with Samsung, with Huawei, that are doing their own neural engine, their own NPU. And on the other side, we have the fabless company like Qualcomm, like MediaTek, like Spreadstrom, that are a bit behind, but they are beginning to propose a new application processor with this neural engine. So all along, we can see that OEMs are handling the whole supply chain from the edge computing even to the AI applications, particularly true for Apple, for example, but it's true for Huawei with the iSilicon brand, and it's beginning to be true for Samsung too. So OEMs are fabless. If you look at this chart, in orange you have the volumes in units shipped of application processor by OEMs, and in gray by fabless companies. And we can see that there is a shift since artificial intelligence has been introduced in smartphones in 2017, 2018. We can see that OEMs get more and more shares, are shipping more and more units of application processor. This is clearly due because AI is a key technology, and this key technology must be handled by OEMs for now. But the other aspect of that is that Huawei is gaining share too. I will not discuss a lot about the trend, the commercial war with US and what Huawei is getting into these days, because it's a bit too soon to discuss about that, but maybe we can discuss later. But what we have seen is that with Huawei entering into the market, there are more and more application processors that have been shipped, obviously with the Kirin 970 and 980. We can see that better in here, where in 2017, mainly Apple have shipped application processor, including artificial intelligence units. And in 18, we have seen the introduction of Huawei that is gaining share there. So what is our forecast? What do we imagine for the future? So again, because AI is key, particularly in imaging, a dedicated hardware is needed. So we expect that in the next year, we expect almost a 50% CAGR. It means that in 4 years from now, in 2023, we expect that 50% of all smartphones will include an application processor with AI computing unit. So there is a clear risk for some competitors to be kicked out of the application market if they do not introduce this kind of unit. The thing is that if we look at what is done today, Apple has proposed artificial intelligence unit, particularly for dedicated for biometry. This is a thing, and it works pretty well. Huawei, they have done the same thing, but it's most around photography. So if we can begin to look at what are the applications that needs artificial intelligence in smartphones, there is already players that are very good at. So what we think is that there is still a place for example, audio artificial intelligence. And that can be something where it's a way to catch up with these players. Let's talk a bit about drone. Drone, it's not really a consumer application, yes, but it's a very interesting applications, very interesting systems, because they can have the constraints of mobile, but it's in a market where we can combine technology from automotive, for example. So it's why we are looking at that. It's a very interesting market. And where we can see artificial intelligence, it's only in mid-end drones or high-end drones. So ASP around respectively $500 and $1,200. In toy drones, I'm not saying that we will never see artificial intelligence, but it's not the case for now, and we think that it will not be the case for at least for the 5 next years. If we look at the landscape for consumer drones, we see that we have 2 big poles with US and China, and we have some companies that are already introducing artificial intelligence. Skydio, which is a startup here, very nice products. We have Over, we have Unique, and obviously we have DJI, which is the biggest players in mid-end and high-end smartphones. And these guys are already using AI technology in their drones. If we look at the SoC, so the computing hardware which is needed to run this type of algorithms, there is only US companies. NVIDIA, Ambarella, Intel, Qualcomm are proposing this kind of SoC where we can see this kind of algorithm runs. What we think is that this will not last. There is, again, this commercial war, but the thing is that we are seeing more and more startups in China that are kind of proposing SoC for this type of application, for robots, for systems that are kind of the same thing of drones, at least the same requirements around drones. And maybe one, we can see that we have Qualcomm, for example, which is proposing solutions for drones. Why not at one point iSilicon can get into that market too? On the supply chains, we can see that this is not the same case as in smartphones. At every steps, we have kind of different players. So for DJI, the computing hardware is made by Intel or Ambarella. For Parrot, Ambarella is the one who give the SoC to Parrot. We have Intel, Qualcomm, NVIDIA that are clients for Unique, for Over, for Skydio. Everything is diversified still. In drones, things are moving fast. It's 1 to 2 year cycle. Things are really moving very, very, very fast. But the thing is, why do we need to use AI in drones? Well, again, AI is key to improve autonomous capabilities. We have seen Jeff talked about that just before. And in drones, we can see that there is 3 different technologies that can be used. The first one is the object detection and obstacle recognition. So the drone identifies obstacles, it avoids it, and anticipates user movement just to follow the user too. We have gesture recognition to control the DOM with the palm, for example. We have finally user authentication and tracking, so face authentication. So the drone identifies its user, films him, and follows him. But what trend, which is very important to understand for drones, is that today, again, we have, it's kind of the same thing what we can see in infotainment for automotive. Everything is controlled mainly by the smartphones. And OEMs want to get rid of that. They want to get everything completely autonomous by itself. If we look at what will happen for Iron Drones market forecast on the penetration rate of artificial intelligence, gesture recognitions and understanding the environment around the drone are the main applications. The thing is that today DJI is the biggest player. It controls 70% of the market of mid-end and high-end drones. And they are already including artificial intelligence. So the trend will follow and will grow. What we think is that in 2023, we think that almost all drones at these prices will include artificial intelligence algorithms and the related computing hardware. Let's talk a bit about a robot home now. So robot home, this is kind of new definition or yeah, whatever. The thing is that for us, smart home is misused. It's kind of an old word, but a smart home, it means more about connected home than a home that is including smart X, okay? So today, what we define robot home as a smart home where devices are driven by artificial intelligence technologies. We will have an image later where you will see all the systems. And these technologies, they are present in imaging and in audio through deep learning for recognition and natural language processing. The trend here in Robotom, what is important is not really, I mean, it's important again, like latency and mobility, but less than what we can see in smartphone. I mean, if you have a smartphone where it takes 5 seconds to unlock your smartphone, yes, it's a problem. For robot home, it's more patient to get the information. When you talk to OK Google or Alexa to get music, if it takes 5 seconds, it's okay. The thing is, what we see and what the Amazon's question we have seen just before, privacy is a key. And because of that, and because of this movement from cloud to edge, this is why we see this movement from cloud to edge. It's because of privacy, which is a huge concern for all the people that want to use this kind of systems. If we look at the forecasts, we divided systems into 2 segments where we have home IoT devices and personal robotics. Personal robotics, we have seen some example already. with a Roomba, for example, which is a good one. We have robot for elderly or companion robots. This is the kind of systems we see in this segment. For home IoT devices, I'm speaking more about virtual assistant where there will be a camera, or the Cocoon Cam, for example. This is a very nice home IoT device where there is a camera. And what we think is that for at least half of IoT devices for smart home which have a camera, computing will be based on either a vision processor or embedded VPU. It depends on what will be the choice of the OEM or the manufacturer. For personal robotics, though, the thing is that we do not see an application processor in a Roomba or in a companion robots, because there will be enough battery to nourish this vision processor, which can be very with very high needs. And for the next 5 years, at least, we see more vision processor dedicated, like a Movidius, like a Mobileye, for this kind of application or systems. So on the road to robot homes, again, to get to this idea of robotic home or robot home, we have different segments with home comfort, with security, with companion robots, with connectivity, with home help, and all these systems at one point will integrate artificial intelligence to get to this idea of a robot home. So let's go to a conclusion. If we talk a bit about number, it's part of my job. The thing is that today, or in 2017, 18, and maybe this year, what we see is that for vision processor, and because this is because of the smartphone market mainly, artificial intelligence for imaging is mainly embedded in an application processor. It's what we see today. And it's what we will see again in a few years from now. But vision processor will get in a hype. We will see more and more systems using a standalone chip to get these algorithms run. I put some information on audio artificial intelligence here, and it's kind of the other way for audio artificial intelligence. It will be more dedicated, implemented through a standalone chips than embedded in an application processor. In terms of value, in terms of revenues, what we see is that today it's still a small market. In 2017, we were around 635 millions. But in 2023, we expect almost more than $23 billion market. And if we look at what is embedded and what is specialized chip or standalone chips, it's kind of the same magnitude, 10 billions for embedded in application processor and 30 billions for specialized chip. So all these approaches of embedded, standalone, sound, audio will have at one point a place in dedicated application. And it's very important for players to understand that and to see where they have to go. So embedded and standalone specialized chip will almost have equivalent revenue, as I just said. So just think about what is my software or what is my application and what are the needs, and this is what I need to go, what I need to do. If we look at the players, I will finish on this slide. This is the value chains. We have 4 types of players. There is let's say, the historical one, which are close to the sensor. They want to add value to the sensors, and they are building chips or embedded computing close to the sensor. These guys are Sony, this is Knowles, onsemi, AMS, and they are doing specialized unit or specialized chip. And this is on the edge, but it's kind of still decentralized in terms of looking at where is the computing in front of the whole computing of the system. There is application processor designer or manufacturer, so Silicon, NVIDIA, Apple, Qualcomm. And behind that, there is all the intellectual property companies with CEVA, Imagine, Xperi, or ARM that are proposing already solutions for all these type of players. And there is these tech giants that today, most of the value coming from the data that are coming through the sensor and through the computing hardware is taken by this company. So I'm talking about the GAFAM or Beitix in China. And these guys are even designing now their own chips. It's particularly true in smartphones, but it's true for in data center, for example, with Google, which is proposing its own chip. So there is today what we see is that there is a tough competition on the edge between computing close to one sensor and centralized, and behind that we have all the value which is taken mostly by the what we call the tech giant. Thank you very much.
Any questions for Tschudi? I guess I'll ask one. So the adoption rate, you were showing IoT in your definition of smart home. Mm-hmm. Are you seeing, and you were sort of showing growth up to sort of 60, 70 million units in a couple of years. Are you seeing different adoption rates across the country? Are people with more privacy concerns in Europe holding back and you don't think they'll take that technology? Versus Asia will go and adopt your definition of smart home quicker? Are you seeing any changes there, or is it all just across the board?
Is the culture important in this kind of the adoption?
I was just guessing whether that might be one reason why certain places would hold back. Are you seeing adoption rates faster in Asia versus the US versus Europe, or?
That's a tough question, but I think that the main issue now, as you said, for everyone, mostly in Europe and US, it's privacy. But because companies have taken in account this privacy problem, I think at one point, the adoption will be the same from Asia, from US, from Europe, if this privacy concern is resolved, for sure.
Right. Okay. One other question, I guess, for you then. You talked about integration. You're saying that the audio stuff will stay as a discrete device. I guess you're assuming that's going to be just because right by the microphone, you're going to put it in a place that's maybe separate away from
exactly.
the main reason. I just wonder whether when you see a drive down to really small devices, whether there would be a volume use case that drives it to a more integrated solution.
I mean, for audio, the thing is that today, what we see, even in smartphone, the DSP for audio is already a standalone chip. It's kind of the culture for audio to have the DSP alone. And at what we can imagine, and that's the thing that we can see when we are interviewing the people that are doing this stuff, is that audio AI is a bit more complicated. It's a bit more tough, and there is less R&D behind than in imaging. And this is the first step to go there, is to implement a sound processor. And then if we are able, in 3, 4, 5 years, to embed that in an application processor. But I'm not saying that we will not see audio AI embedded in an application processor in a smartphone. I'm just saying that it will probably begin with a dedicated chip. It's what we see in the numbers.
Right.
And then with the experience, with all the capabilities of imaging, all what we see in imaging, audio AI is kind of following the trends that imaging has 5 or 10 years before us.
Got it. All right. Tschudi, thank you very much.
Thank you very much.